Okay, so let's go on to question 5 now. So 106 body temperatures were measured. The sample had a mean body temperature of 98.2 with S being 0.62. Use a 0.05 significant sample test to claim that the mean body temperature of the population is equal to. All right, so we have equal to 98.6 degrees. So it's a mean again, right? So it straight out tells us it's a mean. So step 1, find all null and alternative hypothesis. So mu and mu, so equals 98.6. Opposite of equal to is not equal to, so it's going to be a two-tailed test. Okay. All right, now we're on to step 2. Find our test stats. So we have mu, x bar, s, and n. So we know what mu is already. X bar from the data is 98.2. Standard deviation is 0.62. And then sample size, we had 106 itself, right? So now to get our t-value, it's going to be 98.2 minus 98.6 divided by 0.62 divided by square root of 106. Again, doing this first, right? So this should give you a t-value of roughly negative 6.64-ish, about there. Okay. All right, so now we analyze it. So because it's not equal to, this is going to be a two-tailed test. Now, if you guys remember, when it comes to a two-tailed test for t-values, we actually do have to do something very important. We have to divide alpha by 2 because it cuts in half. So since alpha is 0.05, cut that in half gives us 0.025, right? And the degrees of freedom in this case is going to be 105. So if we go back to our table to figure out what our t-values are going to be. All right, so 0.025, which is right here. Go all the way down. Well, closest one is going to be 100, right? So be positive 1.984. Now notice, we should have two of them, right? A negative and a positive. Well, here's the thing. Because of our charts always gives you positive, and it's so symmetric, we could just pop a negative to get the other side itself. So since we're just given this part of the shading portion when it comes to it, to get the other part, we just pop a negative in front of all of them. So it's going to look like that for the next portion. So now our t-value is definitely in here, right? Somewhere way out there. So again, we do reject our null hypothesis. And we do reject it. Okay. So therefore, when we do our last step, which is our conclusion, so since it said equal to, right? It says equal to, so I have equality. So first question, we're going to say yes. Does the original claim have equality? Yes. Right. So yes. Do we reject? Definitely yes. So now we're in box 1. So our conclusion is there is sufficient evidence to warrant rejection of the claim that the mean body temperature of the population is equal to 98.6 degrees Fahrenheit. And that's our complete question there. Right. So why don't you guys try the last two, 6 and 7. So if you just quick pause, 3, 2, 1, pause, and try it, and we'll do them together. So 3, 2, 1, pause. Okay, so hopefully you guys try them out. So 6 says, the trend of Miss America winners has generated charges that the contestants encourage unhealthy diet habits. A sample of 10 BMI's body mass index of recent winners has a mean of 18.1 and a sample standard deviation of 1.5. Use a 0.01 significance level test to claim that recent winners have a population mean BMI less than 20.16. All right, let's see. So it's a mean again, right? So it tells us it's a mean. So first step, find all null and alternative hypothesis. So mu is equal to 20.16, less than, so it's less than 20.16. All right, and we go to step 2. Our mu is 20.16. X bar is In this case, I said mean is 18.7. Sample S is 1.5, and N is, they said, 10. Sample size of 10. Okay. So we'll get our t-value. It's going to be 18.7 minus 20.16 divided by 1.5 divided by square root of 10. So this should give you approximately a t-value of roughly negative 3.07. Okay. All right, so now we go into our portion. So this is a t-value. So alpha in this case is going to be 0.01. Degrees of freedom is going to be 9. So if we go to our chart, let's find our t-value. So 0.01 is here, 9 degrees of freedom. So we should have our t-value of 2.821. Now, here's a catch. What type of test do we have? Right, left, or two-tailed? Hopefully you said left-tailed test, right? It's a left-tailed test because it's pointing to the left, which means instead of a positive 2.821, it's going to be a negative 2.821 because we want a left-tailed test. So therefore, again, just like the other ones, this is a do reject. We do reject our null hypothesis, right? And then from there, we write our conclusion, right? So I'll just quickly go through that. So again, does the original claim have equality? No, because we wanted less than, so no. Do we reject? Yes, so we're in box 3. So the sample data supports the claim that recent wieners have a population mean BMI less than 20.16. Okay. All right, and last one for this section here. So researchers collected a simple random sample of years of 81 college students required to earn their bachelor's degree. They had a mean of 4.8 years and a standard deviation of 2.2 years. Using a 0.05 cumulative sample, test the claim that the mean of years of all college students is greater than 4.5 years. Okay. So mean. So again, told you what mean is. So it's null hypothesis, alternative hypothesis. So mu equals 4.5. And since we want greater, it's going to be mu is greater than 4.5 for alternative. So now we're going to have x bar, mu, s, and n. X bar is, well, from the data, it's 4.8. Standard deviation, they told us is 2.2. And then sample size, 81 college students, right? So find our t-value. It's going to be 4.8 minus 4.5 divided by 2.2 divided by square root of 81. So you should get a t-value of roughly 1.227-ish, approximately. Okay. Rid of ink. Okay. All right, so now we have a right-tail test. So it's area on this side. So alpha is where's our alpha? Oh, right here. 0.05. Degrees of freedom is going to be 80 in this case. So what is our t-value? Okay, so 0.05, 80 degrees of freedom, which is way down here. So 1.664 is our test stat. So it looks like here's our test stat right here, not in the region, so we do not reject our null hypothesis, this one. And then finally, we go to our conclusion. Right? So our conclusion is first, so original claim does not have equality, right? One greater than. So we go no. So do we reject? That's no. So we should be in box 4. So there, the last one is, our conclusion is, there is not sufficient sample evidence to support the claim that, what was our claim? That the mean years of all college students is greater than 4.5 years. And that is hypothesis testing for proportion and mean.